Hello everyone, welcome back to the Math 0332 playlist. I'm Mr. Lee. In the last video we had done reducing fractions mainly and multiplying fractions, but now it's time to look at the other operations between fractions. Division is very similar to multiplication. When you're dividing a fraction, I like to tell my students about the keep, change, flip, in that when you divide by a fraction, you really multiply by that reciprocal. That means something like 4/9 divided by 1/5. You keep the first fraction, you change your division into multiplication, and you flip the second fraction. This mainly has to do with dividing by a fraction. You end up with something in the denominator of the denominator, and that ends up flipping it back to the numerator. So it ends up working like this, and then you can treat it exactly like multiplication. 4 times 5 is 20. 9 times 1 is 9, and then you would look for factors to reduce. This doesn't reduce. This also gives us an opportunity. This, along with 21/2, are what we call improper fractions. They're improper fractions if their numerator is bigger than the denominator. Traditionally, those can be turned into mixed numbers. I prefer improper fractions, but in case your homework wants it in mixed numbers, I'm letting you know those are the types of ones you would turn it into. Similar to multiplying by a whole number, you can divide a fraction by a whole number by writing it as 7/9 divided by 3/1, because any whole number, again, or integer, positive or negative, is that number divided by 1 as a fraction. Now, when you're dividing 7/9 divided by 3/1, much like this first problem, you can keep the first fraction, change your division into multiplication, and then change your second fraction, flip it. So instead of 3/1, it's 1/3, and multiply across. So 7 times 1 is 7, 9 times 3 is 27, and again, you would look for ways that this can reduce, but again, this one doesn't reduce. 3 is very similar. 1/28 divided by 1/8 is now 1/28 times 8/1. When you multiply across, you get 8/28. Now you'll notice that these are both even, so they can be reduced. If you reduce them both by 2, because they're even, divide each one by 2, you get 4/14. But if you see that, you'll notice that they're even again, and you can again divide by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. So this whole thing reduces to 2 7ths. But otherwise, except for keep, change, flip aspect, dividing is very similar to multiplying for fractions. Adding and subtracting are actually a little bit more difficult for most people. Adding and subtracting fractions requires a common denominator. This is why we do the common factor and least common multiple, because they come into play when you do this. So to add or subtract fractions, you need the denominator to be the same. This should be the least common multiple of the denominators if they're different. If one denominator divides into the other one, maybe only one of the denominators has to change, but also potentially both could have to change to meet at a new number. So if the denominators are the same, then you add or subtract only across the top of the fraction. And then you will simplify as needed. So if you're lucky, they're already even. So 1/5 plus 3/5. These already have the same denominator, 5. So that means you just add the numerator, 1 plus 3, and it's still all over 5. That leaves you with 4/5, and that can't be reduced any further. So 1/5 plus 3/5 is 4/5. In number 2, the denominators are not the same. So you're really looking at what do you have to do in order to combine these two things. You need a common denominator. So you're trying to figure out between 4 and 12, what is a number that these both divide evenly into? One way you can do this is you're looking at the factor tree. So 4 equals 2 squared, 12 equals 2 squared times 3. This is kind of a fast forward. You could do the factor tree with these, but I'm going to throw them out there. We know the least common multiple needs everything that's in either one, which means I need 2 2's to cover both of them, but also the 3 to cover the 12, and it just so happens that that means our least common multiple is 12. That means I should expect to get a denominator of 12 on both of these fractions. Now 5 is already over 12. That one doesn't need to change, but I need to figure out what I have to do to the 4 to make it become a 12. And this is a little bit similar to when we converted to decimals in the last video. I need to figure out what 4 needs to be multiplied by to become 12, but whatever I do to the denominator, I'm also going to have to do to the numerator. So it is missing the 3, whereas the 12 isn't missing anything on the other side. When you multiply across, you get 3 twelfths plus 5 twelfths. Once you have a common denominator, you've got 3 plus 5, all divided by 12, which actually ends up being 8 twelfths. However, if you put this in the homework, it would tell you your answer is correct, but not in the most reduced form. So these both have multiples of 4, so you can divide by the common factor to get these two actually add up exactly to 2/3. So sometimes you get a least common multiple, and sometimes when you're cleaning it up, it will get smaller. That's totally normal. I'm going to start number 3 for you. The least common multiple here is 42, which means I want you to practice figuring out how you determine or turn each of these denominators into 42, and then add or subtract from there. Now, subtraction works very similarly. If the denominator is already the same, you just subtract across the top. So 4 minus 2 over 7, which is 2/7. Both of those are prime, so there's nothing to do here. Number 2 is similar to number 2 previously, so I'm going to leave you to do number 2. Only one of the denominators should change here. I want to do at least one where both of the denominators change. 10 and 15. We're looking for a number they both go into evenly. We know 10 is 2 times 5. 15 is 3 times 5. Again, my least common multiple has to cover both of them. So I need a 2 to cover the 10, a 3 to cover the 15, and a 5 to cover both of them. 2 times 3 is 6. 6 times 5 is 30. So I need my denominator in this problem to be 30 before I can combine these. So what is the 10 missing? It's missing a 3. As evidenced by the fact that if you compare the 10 to the least common multiple, it's got the 2 and the 5, but it's missing the 3. Anything you do to the denominator, you also have to do to the numerator. 2/15. 15 is missing a 2. That means we also need a 2 for the numerator. And then from here, we'll clean up. 3 times 3 is 9. 10 times 3 is 30. 2 times 2 is 4. 15 times 2, also 30. So you'll notice that when we do this, we end up with two things with a common denominator, just like we had on number 1, and I can just subtract or add across the top of the fraction. So 9 minus 4 over 30 actually ends up being 5/30. And again, though, when you're done with this, you need to check and make sure to see if this reduces or not. 5 and 30 both share a factor of 5, which means I can divide it out from both parts, and this should end up being, I think, 1/6. Like previously mentioned, if you write 5 over 30 on your homework in the box, it will tell you your favorite response. Your answer is correct, but not in its most reduced simplified form. That's the homework system way of saying, you're right, but haha, I still get to count it wrong. But this is really all of dividing, adding, or subtracting fractions. And we'll pick up in the next video with mixed numbers.